So part E asks us for what values of t is the path of the particle concave up. And so again, the path of the particle is essentially the same as saying the graph of the particle's parametric equation in the xy coordinate plane. And so the normal procedure we learned for this too, for any graph in the xy plane, to find when it's concave up or concave down, we have to, the easiest way to know that is to find that graph's second derivative of y in terms of x, and then make a sign chart of that and go from there. So the first thing I did was find the second derivative of y in terms of x, or d squared y dx squared. But because we're given a parametric equation and our derivatives of x and y are in terms of t, we have to use a different formula than we usually do, and this is the formula. It's d dt of dy dx over dx dt. And so when I just plugged in what I've already found from the first two parts, dy dx is 3t squared minus 12 over 2t, and then dx dt is 2t. And so this top part, the numerator, d dt of 3t squared minus 12 over 2t, we can find using the product rule. It's going to be 2t times 16 minus 3t squared minus 12 times 2 over 2t squared, and then all that over 2t in this formula. And then that simplifies in the end to 6t squared plus 24 over 8t cubed. So that is our equation for d squared y dx squared. And so, or d2y dx2. And so then we need to make a sign chart of d2y dx2, because when the particle's path or graph is concave up, is when its second derivative is positive. And so we just made a sign chart about its critical points, and to find its critical points, we find when this equation is either equal to 0 or undefined. And based on this work, we found that the particle's second derivative, the second derivative of the particle's graph, is never 0. But it is undefined at t equals 0. And so 0 is our one critical point on our sign chart. And when t is less than 0, the second derivative is negative, and when t is greater than 0, the second derivative is positive. And so we're looking for when it's positive, because that's when the graph is going to be, the particle's path is concave up. So our answer is t is greater than 0. An interval notation, that's going to be parentheses 0, comma, infinity.